Alright, and welcome to Quadratic Transformations. Now, in our previous video, The Ultimate Guide to Absolute Value Transformations, we discussed all the effects of A, H, and K in general when transforming a function in vertex form. So we did the heavy lifting in that previous video. If you haven't watched it, I would encourage you to go back. And in working through this video, we see that we have the function f of x equals x squared. Now note, whenever you have x squared, or a power of 2 is your highest degree, you're working with what we call a quadratic function. Now our new function, we're going to apply this rule. Alright, so our rule is g of x is equal to 5f of x plus 2 plus 1. So let's go ahead and tackle this from left to right. The very first thing we see is that our a value, this 5, we know that a is greater than 1. And so this tells us that we have a vertical stretch. We have a vertical stretch, comma. I look inside the function. I look at this x plus 2. Recall, we always set what's inside the function equal to 0. And what gets rid of plus 2? Well, that's minus 2 and minus 2. And so x equals negative 2. So negative 2, well, that's actually going to send me to we're going to say that it translates or shifts the graph to the left 2. I prefer the word shift, but you're going to be tested. You're going to want to use this word translates. And we know that we have this positive 1. Well, that's easy. That just tells us we're going to go up 1. So we'd say that we then go up 1. Easy. Now from here it tells us to write the new function. Okay, so let's write g of x, our new function, is equal to, we know we want to leave a space, and we want to write parentheses x. And then from there, because we're taking this original function, f of x equals x squared, we're going to leave a space, and this is very, very key. You don't want to make this mistake. You want to put a square on the top of this, because we're saying that this function is being squared. Now from here, let's fill in all of our transformations. Our a value became 5, our h value became this positive 2, and our y value became this positive 1. And from here I can actually graph this. I know that my vertex, we already solved for the x value. The x value of the vertex is negative 2, comma, and that k value is 1. So we're going to go to the left 1, 2, and we're going to go up 1, and let's put our vertex. The next thing I know is a is equal to a positive 5. Well, this positive tells me that this graph actually opens up. And the 5, that vertical stretch, tells me it's a very narrow or very skinny graph. So I'm just going to draw that and really accentuate that. Now, in our previous video series, we actually discussed the key features of the graph. And let's go ahead and label those as well. We know that our axis of symmetry cuts through the vertex, through the x value. So our axis of symmetry is at x equals negative 2. Speaking of our vertex, we know it's at the bottom of the graph, so it represents a minimum. And lastly, this graph does not cross the x-axis anywhere. It's above the x-axis. So in fact, what we would say is this has no real solutions. It actually has things that we call imaginary solutions, and we'll learn about those later on in the year. Okay, let's go ahead and do one more example. And in this next example, I'm actually going to show you how to do the entire problem without any math. Okay, in our previous video and in this video, I've shown you a combined, I believe, 3 examples where I've worked everything out very diligently. In this example, what I want to do is show you how to do this without having to write down anything. So let's take a look here. The first thing we look at in this rule is that there's a negative. And I know automatically that this is going to cause the graph to reflect across the x-axis. Across the x-axis. The next thing I see is that there's 3 over 5, it's less than 1. Well, if 3 over 5 is less than 1, we have ourselves a vertical compression. Okay? Alright, comma. I look here, and here I see a negative 2. And I would ask y'all, what is the opposite of negative 2? Well, that's a positive 2, which indicates this function is going to go to the right 2, comma. And here I see a positive 3, which means it's going to go up 3. So I was able to do that all without doing any math. Now, if you're still confused by that, here are the things that I would do. I would say, okay, my a value is 3 over 5. I would write that it's less than 1 because 3/5 is smaller than 1. You would rather have $1 rather than 3/5 of a dollar. Okay? And right here for this x minus 2, you can do x minus 2 equals 0. We know to solve for x, we do plus 2, and we get x is equal to positive 2, which sends us to the right 2. And of course the plus 3 up 3. Now for writing the new function, I write g of x equals, and what I want to do is I want to leave a space, parentheses x, leave a space, parentheses, and remember this is a quadratic function, so I have to make sure that my function is being squared. And from here, our a value is negative 3 over 5. We have x minus 2 plus 3. Well, we know that our vertex is actually at positive 2 comma 3, and our a value is equal to negative 3 over 5. So let's see how this changes the graph. Let's go to the right, 1, 2, up 1, 2, 3, put our vertex. And this negative tells me that we're going to open down, okay? And this 3 over 5, remember that's a vertical compression. We could do the math. We could set this function equal to 0 and solve for our x values. But let's call this a rough sketch, and let's just make it kind of wide, just to indicate, hey, you know what, this thing has been flattened. All right, and there's our graph. Just a couple of things that we would like to note. Let's go ahead and note, you know what, we have our axis of symmetry, which is at x equals positive 2, because it's going through the x value of the vertex. Our vertex is at the top of the function, so we're going to call this a maximum. And lastly, I know that these two places where it crosses the x-axis are my solutions. All right, I hope that this helps, and I'll catch y'all in our next video.